Now this is question number 6B, section C, chemistry 12, BIEK 2025. So here different reactions are given here and we are to write the chemical equations for these reactions. So first one is the reaction of acetaldehyde with zinc amalgam. So the first one is acetaldehyde with zinc amalgam. So actually this is a reduction reaction where acetaldehyde, that is in IUPAC name it is ethanal. So ethanal is there. It reacts with this mixture and that produces hydrogen in nascent form, nascent hydrogen, newly produced hydrogen in atomic form. So we should write zinc, mercury here and HCl because this reaction produces 4H. These are not catalysts, these are the reagents that produces atomic hydrogen. So ultimately what happens? Two hydrogens are added here means they reduce this aldehyde group into alkane, while this oxygen combine with two other hydrogen atoms to form water. So this is a way to produce carbonyl compounds into an alkane. Now the second reaction is reaction of ethane with ozone. So actually there is a typographical error in the paper. It should either ethene or ethyne. So both of them can undergo ozonolysis, that is the part of our syllabus. So first we will see the reaction of ethene with ozone. So those students who have studied in a better way, they got this mistake and they they have done this reaction either with ethene or ethyne. So see if they work with ethene. So what is the reaction? So first we will write ethene and better to write ozone on the arrow because it is a two-step reaction that we will complete it in the single line. So it breaks this double bond and this ozonoid is formed. So this ozonide is formed. When this ozonide is treated with zinc 800 degrees Celsius, according to our book, we got 2 moles of formaldehyde. So 2 moles of formaldehydes are formed with the liberation of zinc oxide. So some of the students definitely attempted this reaction in this way, while some reacted it ethyne. So the reaction should be then ethyne with ozone. So what is the difference? You can see here when ethyne or acetylene react with ozone. Then ozonide is little bit different. Then this is ozone. You can see this reaction on page number 115 of your textbook. So such an ozonide is formed. And then the next reaction is with slightly different reagent, that is zinc and water. So as a result, ethanedial is produced. Ethanedial. That is also called glyoxal. So ethanedial or glyoxal is produced along with zinc oxide. So students have attempted this reaction in this way. Either some of the students attempted with ethene with ozone and some attempted as ethyne with ozone. And some of them left this reaction in choice. So next one is the reaction of Grignard reagent with acetone. So Grignard reagent with acetone. Again, they have not mentioned which Grignard reagent. So Grignard with acetone. So in such cases, you can draw the simplest Grignard reagent, that is methyl iodide, methyl magnesium iodide. I'm sorry. So this is methyl magnesium iodide and reacted with acetone. Acetone is propanone. So propanone is drawn here. So first an intermediate is obtained, that is CH3, CH3 and O, while this magnesium is there with oxygen and this methyl. Actually first methyl attacks on the carbonyl carbon because this is the nucleophile and this is the electrophilic center. Then it is reacted with water. So by this workup, it produces CH3, 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 and OH, along with this byproduct, magnesium hydroxy iodide. So tertiary alcohol is produced here. You can write the name of the tertiary alcohol, tertiary butyl alcohol. This is the common name because they have not asked the name. So you can use the common name as well. Tert-butyl alcohol. Or you can write its name as 2-methyl propanone. 2-methyl propanone. So both are the correct name. The tertiary butyl alcohol is the common name, while 2-methyl propanone is the IUPAC name. and see what's next. Next is the reaction of disonium chloride with heat when heated with water. So benzene disonium chloride, diazonium chloride with water. Remember that this structure is first draw the benzene ring, and on any position, either this one or this one, two nitrogen atoms are with triple bond. As a result, it becomes positive. So if chloride is here, so this is a salt that is disonium chloride. What happens when it reacts with water? As a reaction of water, OH goes to the air and it forms phenol, and it was heated. And these two nitrogen atoms combine to produce nitrogen gas, and H from hydrogen, because OH goes there. So the H combines with H chloride to form HCl. One more thing that in your book, the structure of this disonium chloride is written wrong on page number 174. Here they have written disonium chloride as this. So I think there is an error in the book. This is not the disonium. Correct disonium chloride is this. But definitely the mistake was in the book. So if anyone of you written in this form, it should be accepted by the examiner because this is not your fault. Now the next one is the reaction of the reaction of acetic acid with lithium aluminum hydride. So the reaction of acetic acid with lithium aluminum hydride. This very powerful reducing agent. So whenever we write an equation with any reducing agent, then we prefer in organic reactions that we write only hydrogen here because they provide atomic hydrogen. And at this level, intermediate level or O level, we do not go in detail of the mechanism. So now see what happens. This is the reduction reaction. Only this carbonyl compound, carbonyl carbon is reduced. So what happened? It becomes CH2 and this OH remains there. So ethanol is formed. And where is this oxygen? This oxygen goes to form water. So total 4 hydrogen atoms are needed. 2 for water and 2 are added here. So you can balance this reaction as well. So acetic acid or ethanoic acid can be converted into ethanol by this reducing agent. Now see the next reaction. Now the next reaction is Reaction of ethanol with acetic acid in presence of sulfuric acid. So again, the reaction is with acetic acid, but reagent is change ethanol with acetic acid in presence of acid in presence of sulfuric acid, and little bit heat is also required for this reaction. So what happened? First we will draw ethanol. Even you can draw acetic acid first, no problem. So this is ethanol and this is acetic acid. Even you can draw it in regular form, that carboxylic acid on right side and methyl on other side. But actually I wanted to show that how this reaction occurs, that this hydrogen combines with OH of the carboxylic group. So this reaction requires acid, either sulfuric acid is the best, and it is refluxed. You can use the word reflux or heat both. So what is the product? An ester is formed. So CH3, CH2O, and this part, this acetyl part from the acetic acid. So an ester is formed. The name of the ester is ethyl ethanoic acid. Ethyl ethanoate. The name of the ester ended on oate. This is the suffix for ester. Okay. Now the next reaction is the reaction of bromoethane with KSH. Now see what is bromoethane. Bromoethane with KSH. SH is the thiol group and it acts as nucleophile. So what happens when bromoethane reacts with KSH? This is bromoethane. When it reacts with KSH, so then this thiol molecule attacks on this carbon atom that is electrophilic due to the high electronegativity of halogen. So this nucleophile is substituted there and replace the bromide. And this reaction is called nucleophilic substitution reaction. So the product is CH3CH2SH, while in solution there would be KBr. Remember that this ion is called bisulfide ion or hydrosulfide ion. Means what is SH? SH group is actually bisulfide and its another name is hydrosulfide. but this name is in inorganic compound. So the name of this compound is potassium bisulfide or potassium hydrosulfide. But when it comes into an organic compound, then this is called thiol. So the name of this compound is ethane thiol, and we retain this E because there is no vowel after this. So this is ethane thiol. Now see the next reaction. Next reaction is the reaction of phenol with concentrated nitric acid. So the next reaction is phenol with concentrated nitric acid. And usually heat is also required. So what happens when phenol is treated with concentrated nitric acid? And better to write heat over there. So as a result, trinitrophenol is produced. Polynitration occurs. This is phenol, and 2,4,6 position occupies nitro group. And this compound is trinitrophenol, as well as you can write it picric acid as its common name, picric acid. Okay, now see what next. The next is the reaction of alcohol with concentrated sulfuric acid. So reaction of alcohol with concentrated sulfuric acid. So now they have not mentioned the name of the alcohol. So you can use any of the alcohol. So better to write the smallest alcohol, that is ethanol. So what happens when ethanol reacts with sulfuric acid? When it is heated with sulfuric acid at certain temperature, about 170 degrees Celsius, it produces its respective alkene. So here the alkene would be ethene, and dehydration occurs, OH from here and H from here. So this is a dehydration reaction. So as a result, an alkene is formed. So as we have taken uh, ethanol, so the resulting alkene would be ethene. And the last reaction is reaction of ethyne with water under specific conditions. Reaction of ethyne with water. Ethyne with water. Under specific conditions. So what are these specific conditions? So first we will write ethyne, and we will write the specific condition over there on the arrow. So see what are the specific conditions. The specific condition is the temperature, that is about 100 degrees Celsius, and reaction occurs with certain ratio of sulfuric acid and mercuric sulfate, HgSO4. As a result, what happens? A vinyl alcohol is formed. We have seen the vinyl group, that this is vinyl group. And if alcohol OH group is present, then this is called vinyl alcohol. Then immediately a rearrangement reaction occurs, and it is not required in our syllabus, but remember that rearrangement is always shown with reversible arrow. So as a rearrangement, what happens? This hydrogen goes to this carbon atom. As a result, you will obtain CH3, and a double bond is created here, CHO. This is ethanol. And there is always a reversibility or an equilibrium between alcohol, vinyl alcohol, and the ethanol. This is vinyl alcohol. And the IPC name of this vinyl alcohol is ethene 1-ol. Ethene 1-ol, or simple ethanol, because understood that wherever OH is there, that would be the number one carbon. So you can also write just ethanol. Okay, so that's all for this question.